Hi everyone, in this video we're going to be doing A-Level Further Maths 9231, Paper 12, Further Pure Maths 1, May, June 2025. This paper is 2 hours long, so we'll try to finish within the time limit. So without further ado, let's get started. Okay, so for the first question, we have to use the standard results from our MF19 to show that this result is true, where A, B, and C are integers that we have to determine. Okay, so first of all, to make this simpler, let's first expand our initial expression on the left hand side. So let's write down our expression on the left hand side and just expand everything out. So 2 times 5, that's 10. 2 times negative 3r, that's minus 6r. And then for minus 3r times 5, that's minus 15r. And minus 3r times minus 3r, that's plus 9r squared. So arranging everything together, we'll get 9r squared minus 15 minus 6, that would be minus 21r plus 10. Sorry, give me a moment. Okay, so this is our final expression. Now let's put it back into the summation form. R equals to 1 all the way to n. 9r squared minus 21r plus 10. Okay, so in order to do this, we're gonna have to split the sign. We're gonna have to split the sigma sign into each term. So what I mean is, it will be n r equals to 1 9r squared, and then plus this minus 21r plus r equals to n 10. So it's basically like splitting up the terms when you are finding the derivative or the integral of this type of polynomial. And just like integrating or differentiating, we got to take the constants out of the sigma sign. So for the first term, we're going to take out 9. Then we'll have this. And then for the second term, we'll take minus 21. And then for the next term, since there's just a constant in that term, we can take that out, and the summation of anything like the sigma all from r equals to 1 to n, that would just be n. So this would just be 10n. So you have to be aware of this. It's not given in the formula list. So for the summation of any constant k from r equals to 1 to n, it's just kn. Okay, so you should be aware. Okay, now all we have to do is simplify this remaining term. So to do this, we have to use our MF19. Let me just show it to you right here. Okay, so these are the formulas we have to use. So first, let's use the one for r squared. So this is 9 times 1 over 6n times n plus 1 times 2n plus 1. And now we have to express the one for r. So it's right here. Let's write that down as well. So minus 21 times half n times n plus 1 plus 10n. Okay, so this is all we need from the formula list. Sorry. Okay, now we are going to expand this out, not fully. Okay, let's like first multiply the constants. That's what I mean. But we're not going to expand it fully. Just keep it like this for now, or else the terms would be really complicated for you to simplify. Okay, so from here what we should do is to look for any common factors that we can factor out from all three of these terms that we have obtained. So as we can see, all the terms have n, so we can factor out n, and in order to make each term into a whole number, we're also going to factor out half, because 9 over 6, when you simplify, you'll get 3 over 2. So we'll factor out half n from the whole expression, then we'll get 3 over 2n, that's just 3 times 9 plus 1 times 2n plus 1 minus 21 times n plus 1 plus 20. So this is our factorized form, and now let's try to factorize this even further. So as we can see in the factorized form, the first two terms, they both have a common factor. So we have n plus 1 as well as 3. And since the second term, 21, is a multiple of 3, we can also factor 3 out. So we'll factor out 3 times n plus 1 from these two terms. Then we'll get 2n plus 1 minus 7 plus 20. So let's now expand and simplify everything. So this is 3 times n plus 1 times 2n minus 7 plus 1, that's minus 6 plus 20. And multiplying half n to the whole expression, we would get 3 over 2 times n plus 1 times 2n minus 6 plus 20 times half n, that's 10n. Alright, now let's expand everything out. So 3 over 2n. Let's multiply n plus 1 and 2n minus 6. So n times 2n, that's 2n squared. And 1 times 2n, that's 2n. And n times minus 6, that's minus 6n. So minus 6n plus 2n, that's minus 4n. And to find the constant term, just multiply 1 with minus 6, so that would be minus 6 plus 10n. Okay, now let's just simplify further. So 3 over 2n times 2n squared, that would give us 3n cubed. And 3 over 2n times minus 4n, that will give us minus 12 over 2, which is 6n squared. And 3 over 2n times minus 6, that would give us minus 9n plus 10n. So simplifying all this, we'll get 3n cubed minus 6n squared plus 10n minus 9, which is plus n. So let's see if it fits in our form. Okay, it does, and a, b, and c are integers. So this is our final answer for this question. Let's head on to the next question. So here we're going to have to use the method of differences to find this whole expression in terms of n. Okay, so in order to use the method of differences, we're going to have to express it in like difference in the form of difference, so something like a minus b. And since this is a rational function where the denominator is factorized, we can split this up into partial fractions so that we can express it in terms of difference. So let's do that. So let's write down our factors. So the first term would have the denominator 2 minus 3r, and the numerator would be a constant since the denominator is a linear term, plus b over 5 minus 3r. Since this is also a linear term, the numerator would be a constant. Okay, now let's multiply both sides by the denominator of the left hand side. So this would give us 1 equals to a times 2 minus 3 would cancel out, so we'll have 5 minus 3r, and likewise for b it will be b times 2 minus 3r. Okay, and now let's sub okay, so we now have to sub like a number that makes either of the terms 0, so that we only have to find either a or b. So in this case we'll make 5 minus 3r 0, which we'll have to substitute 5 over 3. So that would give you a times 0, which is 0, so you only have to find b. So that's 2 minus 5, which is minus 3b, equals to 1. This would give you b equals to minus 1/3. And now to find a, you're gonna have to substitute a value of r that would make 2 minus 3r equals to 0. So in that case, that would be 2 over 3. So for a, that would give us 5 minus 2, which would be 3a. That would be equals to 1, so a would just be 1/3. Hence, this final expression would give us 1 over 3 times 2 minus 3r minus 1 over 3 times 5 minus 3r. And to simplify this further, we can see that both of the terms, they have 1/3 as the common factor, so we can factor that out. So this would be 1/3 times 1 over 2 minus 3r minus 1 over 5 minus 3r. Okay, now let's write it in our summation. So all the way from r equals to 1 to n times 1/3 times 1 minus 1 over 2 minus 3r minus 1 over 5 minus 3r. Okay, so as you can see, we have a constant inside of the sigma, so we have to take that out. And now we can evaluate this. Okay, so to do this, let's first find the term when r equals to 1. So that will give us 1 over 2 minus 3, which would be 1 over minus 1. Then minus 1 over 5 minus 3, which is 1 over 2. Plus, now we're going to have to substitute r equals to 2. So this would give us 1 over 2 minus 6. So minus 6 plus 2, that's minus 4. So 1 over negative 4, and then minus 1 1 over 5 minus 3, to that is 1 over minus 1. Okay, so as you can see, this and this cancels out. And now let's continue for r equals to 3 and find the terms, the corresponding terms. So 1 over 2 minus 3 times 3, that would give you 1 over minus 7, and then minus 5 minus 3 times 3, that would give you 1 over negative 4. So again, we can see that this and this cancels out, and we can say for sure now that 1 minus 7 would appear when we substitute r equals to 4 into 1 over 5 minus 3r, so this will also get cancelled out. Okay, now let's just continue the summation and stop at r equals to n minus 1. So substituting that, we'll get 1 over 2 times 3 plus 3n, and then minus 1 over 5 times minus 3n, minus 3n, n minus 1. Oh, sorry, this is supposed to be 2 plus 3n minus 3n, minus 1 over 5 minus 3n plus 3. Okay, now let's just substitute r equals to n, which is the final term of this summation. So this would be 1 over 2 minus 3n minus 1 over 5 minus 3n. So let's see whether we can cancel any terms out here. So as we can see, 5 minus 3n plus 3, that's just 8 minus 3n. Okay, let's look at so the first term, 1 over 2 plus 3 minus 3n, that's just 1 over 5 minus 3n, so we cancel this out. And since we'll get 1 over 5 plus 3 minus 3n we'll also get that when we substitute r equals to n minus 2 as the first term. This will also cancel out. So, and hence, our final answer is 1/3 times 1 over 2 minus 3n minus half. So this is our final answer for this question. Let's head on to the last part. Okay, so now we're just gonna have to deduce the value of the sum to infinity of this expression. So we're just gonna have to use our answer from the previous part and substitute infinity into n. Okay, so as n approaches infinity, so as n gets bigger and bigger, our 1 minus 2 minus 3n, the denominator will get bigger and bigger, so this would approach 0. Hence our answer would just be 1/3 times 0 minus half, which is minus 1 over 6. So this is our final answer for this question and part. Let's head on to the next question. Okay, so here we're told that the cubic equation x cubed plus 2x plus 1 equals to 0 has roots alpha, beta, and gamma. And here we're going to have to find a cubic equation whose roots are alpha cubed minus 1, beta cubed minus 1, and gamma cubed minus 1. Alright, so we're told that alpha, beta, and gamma are the roots of this equation, so it should also be true that alpha cubed plus 2 alpha plus 1 equals to 0, as well as beta cubed plus 2 beta plus 1 equals to 0, as well as gamma cubed plus 2 gamma plus 1 equals to 0. So those should be true. And for our new equation, our roots are alpha minus 1, alpha cubed minus 1, beta cubed minus 1, and gamma cubed minus 1. So this is the same as x cubed minus 1. So therefore, we can substitute, like, we can use this substitution, sorry, y equals to x cubed minus 1, and substitute it into our original equation. We substitute x into the original equation to get a cubic equation in terms of y with these roots. So first let's make x cubed the subject. So here x cubed is just y plus 1, and let's also make x a subject, so that's just x would be the cube root of y plus 1. So this is just y plus 1 to the power of 1/3. Okay, now let's substitute this into our equation. So y plus 1 times 2 times y plus 1 to the power of 1/3 plus 1 equals to 0. Alright, now let's simplify as much as we can. So we'll get y plus 1, that's 2, plus 2 times y plus 1 to the power of 1/3 equals to 0. To make this simpler, let's just make the term with the power of 1/3 as the subject of this equation. So this would be 2 times y plus 1 to the power of 1/3 equals to minus y minus 2. And here we're going to get rid of the rational power that we have. So in order to do that, we're going to cube both sides. Okay, so let's cube the left hand side first. So in order to do that, we're gonna spread the power to both terms, so to both 2 as well as y plus 1 to the 3rd power. So 2 cubed, that's just 8, and y plus 1 to the 3rd power cubed, that's just y plus 1. And now let's expand the left hand side. So, the right hand side, sorry. Okay, so to make this simpler, we're going to first factor out minus 1 from the bracketed expression. So we'll have minus y plus 2 whole thing cubed. So again, we have to spread the power to minus 1 and y plus 2. So minus 1 cubed, that would still give us minus 1. So this is just minus 1 times y plus 2 cubed. Okay, so let's expand the left hand side. So this would be 8y plus 8 equals to minus y plus 2 cubed. That is y cubed. Okay, so for this we're gonna have to use our binomial expansion formula, and the way I like to do it is to use the Pascal's triangle. So it's something like this. So the diagonals would be 1, and to get the middle terms you have to add the previous diagonal. So 1 plus 1, that's 2. So this is 2 for like to the power of 2, but this is not what we're interested in. We're interested in the coefficients when we cube something, so we have to go 1 row further. So 1 plus 2, this is 3, 2 plus 1, this will be 3, and 1. So this would be our equations for our coefficients for our binomial expansion that we have to use. So let's use that. So for our second term, the coefficient would be plus 3 times y squared times 2. And then the third term, it would be plus 3 times y times 2 squared. And then the fourth term, the equation would be 1, so it would just be times 2 cubed. Okay, let's simplify everything in here. So we get minus y cubed plus 3 times 2, that's 6y squared, plus 3 times 2 squared, that is 12, plus 12y plus 2 cubed, which is plus 8. And now let's just simplify everything and move everything to the left hand side. So this would give us y cubed plus 6y squared plus 8y plus 12y plus 8 equals to 0. Hence this would give us our final answer, y cubed plus 6y squared plus 8y plus 12y plus 8 plus 8, that is 16. So this is our final answer for this equation. Let me just check if I'm correct for everything. Okay. Alright. Okay. We're correct. So this is our final answer for this question. Let's head on to the next question. Okay, so here we're gonna have to find the value of alpha cubed minus 1 squared plus beta cubed minus 1 squared plus gamma cubed minus 1 squared. So if you realize, these are just our roots from the previous equation we derived, and is basically the sum of their squares, which we can denote as sigma alpha squared. And there is a formula for this. The formula is sigma alpha bracket squared. By the way, sigma alpha is just the sum of roots, so in this case it's alpha cubed minus 1 plus beta cubed minus 1 plus gamma cubed minus 1. So this is just a sum of roots, please take note of that. And minus 2 times sigma alpha beta. So this is the sum of the root pairs. So alpha cubed minus 1 times beta cubed minus 1 plus alpha cubed minus 1 times gamma cubed minus 1, and so on and so forth. Okay, so to find the sum of roots for this equation, we're gonna have to make use of the equation we found in part A and take the coefficient of y squared, which we'll call b. So we have to take minus b over the coefficient of y cubed, which we'll call a. So it's just minus b over a squared. So that's just minus 6 over 1. So that's just minus 6 squared. And then to find sigma alpha beta, you take the coefficient of y, which we'll label as c, and divide it by a. So that's just 8 divided by 1, which is 8. And just type this into your calculator. You will get 20 as your answer. So this is our final answer for this part. Let's head on to the next question. Okay, so here we're going to have to find the value of the roots cubed this time, the sum of the roots, the sum of the cubes of roots, whatever you want to call it. That's the best way I can express it. Okay, so in order to do this, there's also a formula for this, but the way I like to go is to use the substitution method. So first of all, let us define Sn to be equal to alpha cubed minus 1 to the power of n plus beta cubed minus 1 to the power of n plus gamma cubed minus 1 to the power of n. Okay, so let's reference our previous equation. So we have y cubed. Now we replace that with s3. And then for the y square, we'll replace it with s2, and for y we'll replace it with s1, and so on and so forth. Oh, I just realized, sorry, I have not simplified this. This is supposed to be 20y. Okay, so yeah, so this is the final answer, y cubed plus 6y squared plus 20y. Wait a minute. Oh, okay, sorry, this means that my answer here is wrong. Okay, let me just quickly correct it. So this would be c over a, which is 20 in this case. So typing that, you'll get 36 minus 40, which would be minus 4. So this is the final answer for part B. Okay. Alright, yep, okay, so, oh, sorry, we're a bit too ahead of ourselves. Oh my gosh, this new software. Alright, so, like I said, now instead of y, we're going to write s1, so 20 s1, and for the constant term 16, we'll write 16 times s0 equals to 0. So we want to find s3, if you can see from here, and we already know s2, which is our previous answer in here, that's minus 4, plus 20 times s1. S1 is just the sum of our roots, which we also found in our previous part, that's minus 6. And s0, that's just, okay, if you substitute n equals to 0, you'll get 1 plus 1 plus 1, which is 3, okay, equals to 0. So simplifying all this, you will get 6 times negative 4 plus 20 times negative 6 plus 16 times 3. That's minus 96 equals to 0. So the final answer would be 96. So this is our final answer for this question, for this part, and we're done with this question. Let's head on to the next question. Okay, so here we're told the sequence u1, u2, u3 is such that u1 is equals to 5 and un plus 1 equals to 6 un plus 5 for n is greater or equals to 1. And for the first part, we have to prove by induction that this result is true for all positive integers n. Okay, so to conduct proof of induction, there are a series of steps that we have to use for all types of questions, like talking about sequence or differentiation, divisibility. Okay, wait, not divisibility, you know, like sequences, yeah, everything other than divisibility, it's the same general process. So the first step is we should let n equals to 1, and we should find out what n equals to 1 gives us. So u1, we're already told, is equals to 5. And now let's use this result on the right hand side and substitute n equals to 1. So that's just 6 to the power of 6 to the power of 1. That's 6 minus 1. So now check whether both sides match. Yes, 6 minus 1 is equals to 5. So here you can say a case for n equals to 1 is true. So the first step is to show that your initial n value, the starting n value, the case is true. It may not be n equals to 1, it could be n equals to 2. So read the question carefully. Okay, so now we're going to assume that it's true for n equals to k, where k is a positive integer. So we're basically assuming that uk equals to 6k minus 1 is true. Okay, so this is the second step, and now the third and final step is to let n equals to k plus 1. Okay, now we're going to find uk plus 1. So just substitute into this equation we're given that we have to prove. So this would be equals to 6k. Wait, sorry. No. Okay, so what we have to do is to use all this information that we're given, and from there we're gonna have to manipulate it in such a way that we get our original result back. So we have to use all this information, and our final answer should be 6 to the power of k plus 1 minus 1. Okay, so here, as we can see, we are told that un plus 1 equals to 6 un plus 5. So this would be 6 times uk plus 5. And now we also assume that this is true. So let's use this result, 6 times 6k. Minus 1 plus 5. So let's simplify everything. So 6 times 6 to the power of k, that's just 6 to the power of k plus 1, using our law of indices, and 6 times negative 1, that's minus 6 plus 5. So simplifying, we'll get 6 to the power of k plus 1 minus 6 plus 5, that's minus 1. So let's okay, let's see if it's in our form. Yep, it is. uk plus 1 equals to 6 to the power of k plus 1 minus 1. So here we can write down, since true for n equals to k, it's also true for n equals to k plus 1. And hence we can write our final statement. Hence, by principle of mathematical induction, the above statement is true. So the above statement is just this equation that we have to prove. Okay, so this is our final answer for this part. Let's head on to the next part. So here we're just gonna have to deduce that this is divisible by un for n greater than or equals to 1. Okay, so for this, we're gonna have to use our result from the previous part. So just substitute n equals to 2n. So u2n is just 2 to the power of 2n minus 1. And now we can rewrite 6 to the power of 2n by swapping the powers. Is the same as 6 to the power of n squared minus 1. And using our difference of squares, we can actually factorize this to get 6n minus 1 times 6n plus 1. And guess what? 6n minus 1 is actually equals to un. So here we can write un times 6n plus 1. And then from this, you can obviously see that u2n is divisible by un because un is a factor of this. So un is a factor of u2n, so divisible by un. Okay, so this is our final answer for this part, and we're done with this question. Let's head on to the next question. Alright, give me a while. Okay, so for this question, we're told that the matrix M is given by this, where theta is between 0 and 2 pi. For the first part, we're told that the matrix M represents a sequence of 2 geometrical transformations in the xy plane. So basically just the 2D plane. We have to state the each type of transformation, and we have to make the order clear in which they're applied. Okay, so first of all, in order to do this, we have to know that the matrix on the left, like when we're given a product of two matrices, the one on the right hand side is the first one, followed by the one on the left hand side, the second one. So it's always the one on the right hand side followed by the one on the left hand side. So the first transformation is represented by this matrix cosine theta minus sine theta, cosine theta. So this is actually an anti-clockwise rotation. Anti-clockwise rotation about the origin by theta. So this is anti-clockwise rotation about the origin through angle theta, followed by this second transformation represented by 1, 2, 0, 1. So to get a better idea of what this is, we are going to just sketch like our XY plane. And let's draw a point. Okay, let's draw this point on the y-axis. Let this be 1. Yeah, wait, no, this is 0, 1. Yeah, 0, 1. Okay, now let's multiply this matrix by 0, 1. So you can do it on your calculator or on your or manually. So you know what, let me just do manually. So 1 times 0 times 2 times 1, that would give us 2, and 0 times 1, 0 plus 1, that is 1. So our final coordinates is 2, 1. So it's right here. Okay, so 2, 1 is right here. So it's from this to this, so it has shifted over here. So as you can see, the points, the y coordinate did not change, so we can say that the x-axis is fixed, okay, because the y coordinate didn't change. So this is actually called shear, okay. This would be a shear, x-axis fixed. And one more detail, we have to write down the points with 0, 1 mapped onto 2, 1. So this is our final answer for this part. Let's head on to the next question. Okay, so here we're gonna have to find the value of theta, for which the transformation represented by m has a line of invariant points. So it has a line of invariant points. Okay, so let's start the procedure for finding the equation of an invariant line. So an invariant line is basically a line or a point that remains the same after a transformation has been applied by a matrix. So let's say we have our point 1, 0. When it's applied by a matrix, it will, if it remains 1, 0, it's invariant. And we have to know that the origin is an invariant point. The origin never changes no matter what transformation you apply. Okay, so let's start. So let's write down the m. Okay, let's first figure out what m is by multiplying. So m is 1, 2, 0, 1 times, okay, cosine theta minus sine theta, cosine theta. Alright, so to multiply matrices, we first have to see the number of columns and rows. So here, the first matrix, there's 2 columns and 2 rows, and same for the second one, 2 columns and 2 rows. So now we have to see whether the number of rows on the first matrix and number of columns on the second matrix are the same. So as we can see, they are the same. So our resultant matrix would be a 2 by 2 matrix. So there will be 2 columns and 2 rows in here. So let's first find the first element on the top left hand corner. So to do that, we have to first know that it would be in the first column, first row. So we have to multiply by the first row of the first matrix and multiply it with the first row of the second matrix and add them up. So we have to multiply 1 times cosine plus 2 times sine. So that will give us cosine plus 2 sine. So cosine theta plus 2 sine theta. Now to find the element on the top right hand corner, we are going to have to know that it's in the first row and second column. So to find that, we're going to have to multiply 1 with sine plus 2 times cosine. 1 times negative sine plus 2 times cosine theta. So this would be 2 cos theta minus sine theta. Okay, now to find the third element, it's in the second row, first column, so we multiply by the second column of the first matrix times the first row of the second matrix. So multiply 0 times cosine plus 1 times sine theta. So this would be sine theta. And for the last term, we multiply 0 times sine and plus 1 times cosine. So that would just give us cosine theta. So this is our matrix M. Okay, so let's now write it with our invariant points. So we'll just let them be x, y. The line be x, y. Okay, so cosine theta plus 2 sine theta 2 cosine theta minus sine theta sine theta cosine theta times x, y, but we are finding a line of invariant points, so the line we can write as y equals to mx, because all invariant lines, they pass through the origin, since the origin is always invariant. So we can write this down as mx, and this equals to big X and big Y, which is also just m big X. Okay, so now let's simplify the left hand side. So let's multiply it again. So this would be, this is a 2 by 2 matrix times a 2 by 1 matrix, and we can see it's the same, so the resultant matrix will be a 2 by 1, so it'll just be a column vector. So in order to do this, we're gonna have to multiply cosine plus 2 sine theta with x, so this would be x times cosine theta plus 2 sine theta, and plus mx times 2 cos theta minus sine theta plus mx times 2 cos theta minus sine theta. And to find the second element, you're gonna have to multiply x times sine theta, so x sine theta plus mx cos theta plus mx cosine theta equals to x mx. Okay, so now we're gonna convert this into a fraction, so just put like a fraction sign over the two columns. Yeah, so this is what I mean. You'll see it in a short while. And then let's do the same for the right hand side, so x over mx. So as you can see, we can cancel out the x's, and we can also cancel out the x's for here, like we factorize it out and we can cancel. So this would give us cosine theta plus 2 sine theta plus 2m cosine theta minus m sine theta over sine theta plus m cosine theta equals to 1 over m. Alright, now let's cross multiply everything. So this would give us m cosine theta plus 2m sine theta plus 2m squared cosine theta minus m squared sine theta equals to sine theta plus m cosine theta. Okay. So if you can see, we have m cosine theta on both sides, so let's just cancel that out. Okay, and now let's move all the terms to the left hand side. So this would give us 2m squared cosine theta minus m squared sine theta plus 2m sine theta minus sine theta equals to 0. Alright, so this would be 2 cosine theta minus sine theta m squared plus 2 sine theta m minus sine theta equals to 0. So as you can see, we have obtained an equation in terms of theta and m. So the reason why that is we have to find the value of theta, which there is a line of invariant points. So if you think about it, to have only one invariant line, there should only be one value of m. So using our discriminant b squared minus 4ac, we're gonna have to equate it to 0. So let's find out our b squared minus 4ac and equate it to 0. So our b is 2 sine theta, so 2 sine theta squared, that's 4 sine square theta, and then minus 4 times a, which is just the coefficient of m squared, so that is 4 times 2 cosine theta minus sine theta times c, which is just minus sine theta, so times minus sine theta equals to 0. Oh, sorry for the random scribbles in here. Okay, let's simplify everything. Sine square minus 8 cosine theta plus 4 sine theta. Okay, wait, no. Let's multiply minus 4 and minus sine theta together. So this would be plus 4 sine theta times 2 cosine theta minus sine theta equals to 0. Then 4 sine square theta plus 8 sine theta cosine theta minus 4 sine square theta equals to 0. So as you can see, we have again 4 4 sine squared theta minus 4 sine squared, so we can cancel those out, and we can factor out 4. So this would be 4 times 2 sine theta cosine theta equals to 0, and 2 sine theta cosine theta, if you remember from our trig identities, let me just pull up the MF19 in here. Oh, okay, alright. Yeah, it's right here, as you can see. So we can rewrite this 4 sine 2 theta equals to 0. Okay, now we can solve this equation, so let's divide both sides by 4, so we'll just have sine 2 theta equals to 0. So as you can see, theta is between 0 and 2 pi, so we're gonna have to change for this by multiplying 2 on both sides. So for 2 theta, it will be between 0 and 4 pi. So hence our 2 theta would be 0 pi, 2 pi, three pi, and 4 pi. And then theta would just be equal to 0 pi over 2 pi, 3 over 2 pi, and 2 pi. So let's see which of these fit our criteria. So we have to reject 0 and 2 pi immediately. Okay, let's see if cosine 2 pi is possible. Okay. Okay, so here I have a feeling that the answer, just to be safe, is pi. So theta is equals to pi, because we can actually factor out cosine theta, and this would give us an equation in tangent theta, and we know that tangent pi over 2 doesn't exist. So yeah, our final answer is theta equals to pi. So this is our final answer. Let's head on to the next question. Okay, so here we're told that the curve C has this polar equation r equals to theta times e to the power of 1 over 8 theta for this domain between 0 and 2 pi inclusive. For the first question, we have to sketch C. Okay, so to sketch the polar curves, we need to know that theta is the angle from this initial line, theta equals to 0, so it's the angle, and then r is the distance from here. This is called the pole, this dotted, the place where I dotted it. So substituting, so to do this, we have to basically just substitute values of theta to find the corresponding values of r. So substituting 0 you will get r equals to 0, so it would just be here. And then as you substitute bigger values of theta, r also gets bigger, so the distance from the pole gets bigger, so it's like this. Yeah, so this is, it's like a spiral shape. Yeah, this is like the more correct shape. But okay, you know what, let me resketch that. So it starts off small and then it slowly gets bigger. Yeah, so this is the rough shape of this polar curve with this equation. So to sketch any polar curves, just substitute values of theta into the equation for the given domain. So this is our final answer for this part. Let's head on to the next question. Okay, so here we're gonna have to find the area of the region bounded by C and the initial line, giving your answer in this form, where P, Q, R, and S are integers to be determined. Alright, so in order to find the area bounded by a polar curve, we have to use the formula half times the integral of r squared d theta. And for our limits, it would basically be the values of theta that the part of the graph that we're trying to find the area of starts and ends at. So in this case, it's from 0 to 2 pi, so our limits would be just that, 0 and 2 pi. Okay, so first of all, let's write down our full integral. So r squared would just be theta squared times e to the power of 1 over 8 squared. So to do that, just multiply the powers. You would get 1 over 8 theta times 2, which is 1 over 4 theta d theta. Okay, so here, if you can see, we actually have to do integration by parts to solve this integral. So let's use a much quicker method of integration by parts that I've learned from a YouTube video. I'm sure it's also acceptable to be used in your exams. So it's the DI method, and you have to add like a bunch of plus signs. You have to start off with the plus sign and the minus sign and the plus sign. Okay, so the function which you set as D, it's similar to choosing it as your U. So here we're gonna choose theta squared. Okay, good. Alright, sorry. So here we're gonna choose our theta squared as our D or U, and our e to the power of 1 over 4 as our dv or as our I. So let's first differentiate the theta squared under D. So this would just be 2 theta 2 and 0. And then for the I, we'll just have to integrate it over and over again until it reaches 0. So e to the power of 1 over 4 theta, that's 4 times e to the power of 1 over 4 theta, and then integrating it again, you'll get 4 times 4 to the power of e to the power 4 times e to the power of 1 over 4 theta, that's 16 e to the power of 1 over 4 theta, and finally integrating it again, get 16 times 4 equals to 64 times e to the power of 1 over 4 theta. So in order to get the final integral, you take the product of the diagonals across, and these, the ones horizontal, it would be your integrals. Okay, if you can understand this method, don't worry, just stick to your normal integration by parts. But in here I can't find enough space to do it, so I'm just gonna do this method. So final integral would be plus 2 theta squared times 4 times e to the power of 1 over 4 theta. That would be 4 theta squared times e to the power of 1 over 4 theta. Then minus 2 theta times 6 to the power of e, minus 2 theta times 16 to the power times e to the power of 1 over 4 t. So this is minus 32 theta times e to the power of 1 over 4 theta, and then plus 2 times 64 times e to the power of 1 over 4 theta. So that's 128 times e to the power of 1 over 4 theta with respect to these limits. Okay, so let's substitute our limits. Okay, so substituting 2 theta, we'll get 4 times 2 theta squared, which is 4 pi squared. Okay, so that's 16 pi squared times e to the power of 1 over 4 times 2 pi, which is pi over 2. And then minus 32 times 2 pi, that is minus 64 pi times e to the power of 1 over 4 2 pi, that is again pi over 2, plus 128 times e to the power of 1 pi over 2. And then minus, just substitute 0. So substituting 0 for the first two terms, that's just 0. So don't have to care, that's just minus 0 plus 0 minus 128 times e to the power of 0, so that's just minus 128. Okay, now let's expand this out. Okay, so this would be 8 pi squared e to the power of pi over 2 minus 32 pi e to the power of pi over 2 plus 128 e to the power of pi over 2 minus 128. So let's factor out e to the power of half pi for the first three terms, so as to like get our answer in the required form. So this would get us 8 pi squared minus 32 pi plus 128 pi times e to the power of half pi minus 128. So this is our final answer for this question, and if you want to check whether your integration is correct, just type the original integral or the whole expression into your calculator if it's possible, and check whether your answer matches with this expression in your calculator. So without further ado, let's head on to the next part. Okay, so here we have to show that at the point C furthest from the initial line that this expression is valid, and we have to verify that this equation has a root between 5 and 5.05. Okay, so this question has two parts. So first we have to derive this equation. So in order to do that, we have to know what's the property of the point furthest from the initial line. So going back to our diagram, so this is the initial line, theta equals to 0. So the point furthest from the initial line is the highest or the lowest point. So the point that has the biggest vertical displacement. So it's like either here or here, the biggest one. Doesn't matter whether it's up or down. So it's like the maximum or minimum, the greatest or biggest y value, okay? So it's supposed to be y equals to r sine theta. So this is supposed to be, wait, let me erase sine theta. Okay. Alright, how about we just restart? Okay. So, yeah, y is equals to r sine theta. And, yeah, let's just equate theta times e to the power of theta times e to the power of 1 over 8 theta sine theta, and dy d theta. Let's differentiate. So going to keep the sine theta first and differentiate theta times e to the power of 1 over 8 theta plus theta times e to the power of 1 over 8 theta cosine theta equals to sine theta times 1 over 8 theta times e to the power of 1 over 8 theta plus e to the power of 1 over 8 theta plus theta times e to the power of 1 over 8 theta cosine theta. Okay, let's okay, now let's equate it to 0. Okay, so we can divide this whole equation by e to the power of 1 over 8 theta, okay, like I said. So this would give us sine theta 1 over 8 theta plus 1 times theta cosine theta equals to 0. And then you would get theta cosine theta plus 1 over 8 theta plus 1 sine theta equals to 0. So as you can see, we have proved our equation, so we can write shown. Okay, and to and now we have to do the second part of this equation. We have to verify. Okay, so to do that, just substitute the respective values. So let's substitute theta equals to 5. So this would be 5 cosine 5 plus 5 over 8 plus 1 sine 5. That's equals to, make sure your calculator is in radian mode for this. So we got a negative value, show it to 3SF, so 0.140 to 3SF. And now substitute theta equals to 5.05. So this is 5.05 cosine 5.05 plus 1 over 8 times 5.05 plus 1. This is 261 over 160 times sine 5.05 equal to sine 5.05. So we got a positive value 1.134 to 3SF. So you can see there's a sign change in here. So you can say since there is a sign change, theta the root is between 5 and 5.05, verified. So this is our final answer for this question. We're done with this whole question, so let's head on to the next part. Give me a break. Okay, so for this we have points A, B, and C with these position vectors. So this is point A, I minus 2k, this is point B, and this is point C. For the first question, we have to find the equation of the plane ABC, giving your answer in the form this. So we have to give our answer in the Cartesian form. Okay, first of all, we have to find the normal to the plane, and in order to find that, we have to take any two direction vectors in our plane ABC. So from what we can, like when we sketch, so this is our plane ABC, we can see we have two direction vectors, plane ABC. Actually we have three, but let's just choose two. So I'm going to choose AB and AC. So AB would just be OB minus OA, which is, okay, let me just shift it, okay, which is 1, 2, 2 minus minus 1, 0, minus 2, and this would give us 0, 2, 4. Now let's find AC. So that's just OC minus OA. So OC is 2 minus 1 minus 1 minus OA 1, 0 minus 2, 2 minus 1, that's 1 minus 1, 1. So these are our direction vectors, which we're going to use to find the normal. So to find the normal, just take the common the vector product of these two vectors, which gives you the common perpendicular. Oh my, so many scribbles. Okay, so let's list them down in IJK format. So AB is 0 to 4, and this is 1 minus 1 1. So in order to do that is almost the same as finding the determinant of a matrix. So in order to do this, to find the determinant of I, cover the I row. Whoa, okay, wait. Alright, covered the, oh my. Alright, covered the I and the row and column. So the determinant would be 2, 4, minus 1, 1. Okay. Oh my gosh. 1. Okay. And now minus times minus j, the determinant of this. So it will be 0, 4, 1, 1. So 0, 4, 1, 1. And then plus k. To find the determinant of that, the first row and this, so it's 0, 2, 1, negative 1. So 0, 2, 1, negative 1. So this would give you the determinant of this 2 minus negative 4, that is 6. And determinant of 0, 4, 1, 1, that's 0 minus 4, which is minus 4. Wait, no, minus 4 times negative 1, that's 4. Sorry. Yeah, and then 0 minus 2, which is minus 2. Now we can actually divide all the components by 2 to make it simpler. So this is simply just 3 to negative 1. And now we're going to, now we have found, okay, so to find the full equation, we now have to substitute a point that is on the plane. So we can substitute either A, B, or C. So I'll substitute point A, which is 1, 0, negative 2. So 3 times 1 plus 2, 0 times minus 1, negative 2 equals to 3 plus 0 plus 2, that's 5. Hence, our answer is 3x plus 2y minus z equals to 5. So this is our final answer for this part. Let's head on to the next part. Okay. So here we're told that a point D has this position vector ITK. So in column vector is 1, 0, t, where t is not equals to negative 2. So for this part, we have to find the acute angle between the planes ABC and ABD. Okay, so in order to find this, let's first draw like a representation. So this is, let's say, ABD, and then this is ABC. Okay, so and then this is, okay, that's not, okay, this is the acute angle, theta. So to find this, we have to find the normals of these two vectors. Okay, and then find the angle between the normals of these two vectors. So if we get an acute angle as the angle between the normals, that would also be the angle theta that we're looking for here. If the angle here, yeah, okay, so if we get angle theta like to be acute, right, we're going to do it. All right, we're going to equate it like as you can see from this diagram, like, okay. Sorry. All right, so if the angle between the normals is an acute angle, then that means this main angle here is obtuse, which is not the angle we're looking for. So we have to use this other angle, which is just the same as the angle between the normals. Okay, there we go. So that's the explanation. So let's get to work. So we already know the normal to the plane ABC. It's in the equation of the plane. So now we have to find for ABD. So to do that, again, we have to find two direction vectors in this plane. So we can see already AB is 1. So that's just, okay, we found that. That's just 0 to 4. And we have to find the other one, AD, which is just OD minus OA. So OD is just 1, 0, T minus OA, which is 1, 0 minus 2. 1, 0 minus 2. This would give us 0, 0, T plus 2. Okay. Now we have to find the common perpendicular, aka the normal to the vector ABD. So this is 0, 2, 4, 0, 0, T plus 2 equals to I. Cover these up, you'll get determinant of 2, 4, 0, T plus 2 minus J should be 0, 4, 0, T plus 2 plus K. Covered these two up, 0, 2, 0, 0, 0, 2, 0, 0, and we would get I as 2 times T plus 2 minus 0, so yep, 2 times T plus 2, and then 0, 0, that's just 0, and then for K it's also just 0. So simplifying, okay, okay, wait a minute. Okay, sorry. Okay, yep, I think it's possible for us to simplify this. Okay, so we can just divide everything by 2 times T plus 2, which is 1, 0, 0. Okay, so now we are going to use the scalar product to find the angle between the normals. Okay, so let's just take the dot product of the normals, 1, 0, 0 times 3, 2 minus 1, 3, 2 minus 1 equals to the magnitude of these two normals. So first one is just 1 times 3 squared plus 2 squared plus negative 1 squared, which is 9 plus 4, 13 plus 1, which is 14 cosine theta. So cosine theta would just be 3 over square root 14. So as you can see, cosine is positive, so that means theta is acute, okay? Hence, we can just take the inverse to find our final answer. So theta equals to cosine inverse 3 over square root 14. You can do it in either degrees or radians. In this case, I'm going to do it in degrees. You'll get 36.7 degrees to 1 decimal place. So this is our final answer. Let's head on to the final part. Okay, so here we're going to have to find the values of t such that the shortest distance between the lines AB and CD is square root 2. Okay, so here we're going to, let's draw a sketch first of the lines AB and CD. So the shortest distance would be this, and this line would be perpendicular to both AB and CD. Okay, so this would definitely be a common perpendicular between them. So to find the direction vector of this, we have to take the vector product of AB and CD. Okay, now let's make a line joining up the vertex, the ends of either line. So here I'm going to form the line AC. Yeah, okay, we found it in the previous part. Alright, so this AC cosine theta, this angle between AC and the common perpendicular, the angle between them is theta. Okay, so okay, we're gonna let this common perpendicular be N. Okay, or just okay, let this be AB times CD. So this is also AB times CD because it's parallel to the common perpendicular. To find the magnitude of this is just the magnitude of AC cos theta. Okay, so the shortest distance is AC times cosine theta, and to find the cosine theta, we're gonna have to use our scalar product. Okay, so it's just the dot product of the two vectors. Okay, it's the dot product of AC and the common perpendicular. So AB times CD dotted with AC over the magnitudes of AB times CD over the magnitude of AC. So as you can see, the magnitude of AC cancels out, so this is our final equation. AB, the vector product of AB and AC dotted with AC times the reciprocal of the magnitude of the common perpendicular. Okay, so first let's find the common perpendicular. So do we know CD? Okay, we don't. Okay, first of all, let's find CD. So CD is just OD minus OC. So OD is just 10T minus OC, which is 2 minus 1 minus 1. 2 minus 1 minus 1. So that's minus 2 plus 1, that's minus 1. 1 plus 0 plus 1, that's 1. And T plus 1, which is T minus negative 1, which is T plus 1. Okay, now let's find the common perpendicular. IJK ABC. So AB is 0, 2, 4, 0, 2, 4, and CD is minus 1, 1, T plus 1 equals to I, that would be 2, 4, 1, T plus 1, minus J, that's 0, 4, minus 1, T plus 1, plus K, 0, 2, minus 1, 1. So I would be 2T, 2 times T plus 1, which is 2T plus 2, minus 4 times 1, which is minus 4, minus J times 0 times minus negative 4, which is just 4. Okay, and then plus K, 0 minus negative 2, which is 2. So we will get minus 4 plus 2, which is 2T minus 2, minus 4, and 2. We can simplify this by dividing by 2, so this would be T minus 1 minus 4, wait, no, minus 2, 1. Okay. Alright. Now let's substitute all this into the equation we formed. So AC is just 1 minus 1, 1. 1 minus 1, 1. Times square root of the common perpendicular, which is just T minus 1 squared, plus minus 2 squared, which is 4, plus 1 squared, which is 1, so 4 plus 1, that is 5, equated to square root 2. So we'll have, so just multiply, we'll have square root 2 times T minus 1 squared plus 10 equals to T minus 1 plus 2 plus 1. So minus 1 and 1 cancel, so we'll only have T plus 2. And to get rid of the square, just square both sides. We'll have 2 minus 2 times T minus 1 squared plus 10 equals to T plus 2 squared. Okay, now let's simplify everything. So 2 times T squared minus 2T plus 1 plus 10 equals to T squared plus 4T plus 4. Okay, now we'll get 4T plus 2 plus 10, which is plus 12, equals to t squared plus 4t plus 4. So this would give us a final equation: t squared minus 8t plus 8 equals to 0. Okay, now let's solve this equation. So you can either factorize or use the quadratic formula. Okay, let me use the quadratic formula here. So this is minus b, which is just b, plus minus b squared minus 8 squared, which is 64, minus 4 times a times c over 2a. So this would give us t equals to 4 plus 2 square root 2, and t equals to 4 minus 2 square root 2. So this is our final answer for this question. These are values of t. Let's head on to the next question. Okay. Oh, sorry, thought it stopped recording. Okay, alright. Now let's get on with the final question. The curve C has this equation. It's a rational function. So the first part, we need to find the equations of the asymptotes of C. Alright, so in order to do that, so to do that, we first have to divide the whole equation, since, as you can see, the degree of the numerator is 2, same for the denominator, so we have to do long division first. Okay, so, or we can just like divide the coefficients of the numerator and denominator by each other. So numerator divided by denominator, so 2 over 2, we will get y equals to 1 as our horizontal asymptote. Okay, and now let's to find the vertical asymptote, just equate the denominator into 0 and solve for x. So let's factorize the equation. So this would be x minus 4 times 2x plus 1 equals to 0. So we'll have x minus 4 equals to 0, so this would be x equals to 4, and 2x plus 1 equals to 0, so this would get us x equals to minus half. So these are our vertical asymptotes, and this is our final answer. Let's head on to the next part. Okay, so here we're gonna have to find the coordinates of any stationary points on C. Okay, so first of all, let's copy down our equation. Y equals to 2x squared minus 5x equals to 2x squared minus 7x minus 4. Then dy dx is equals to 2x squared minus 7x minus 4 squared. We have to use the quotient rule here, so squaring the denominator and then multiply by the denominator times the derivative of the numerator, so that's just 4x minus 5, and then minus the numerator times the derivative of the denominator. So that's just 4x minus 7. Okay, so dy dx equals to 0. So that we can just equate the numerator to 0. So let's simplify the numerator. So first we have to expand. So expanding, we'll get 2x squared plus 4x, which is 8x cubed. And then to find x squared, it's just 2x squared minus 5, which is minus 10x squared. And then minus 7x times 4x, which is minus 28x. So minus 10x minus 28x, that's minus 38 x squared. And now to find the x term, just minus 7x times minus 5, which is 35x, and minus 4 times 4x, which is minus 16x, which is plus 19x, and then minus 4 times minus 5, which is 20, and then minus 2x squared times 4x, which is 8x cubed, and then x squared is 2x squared minus 7, which is minus 14x squared, minus 20x squared, which is minus 34x squared. And then to find the x term, minus 5x times minus 7 is plus 35x equals to 0. So simplifying this, we'll get minus 38x squared plus 34x squared, which is minus 4x squared, 19 minus 35 minus 16x plus 20 equals to 0. So divide all the coefficients by negative 4, so we'll get x squared plus 4x minus 5 equals to 0. So solving this, just type it into your calculator or factorize. So x minus 1 times x plus 5 equals to 0. So x minus 1 equals to 0, x equals to 1, and x plus 5 equals to 0, x equals to negative 5. But here we want the coordinates, so we have to also find the respective y values. So y, just type it into your calculator. 2 times 1 squared minus 5 times 1 times 2 times 1 squared minus 7 times 1 minus 4. You'll get y equals to 1/3. And then for this, you'll get, for x equals to negative 5, you get 2 times negative 5 squared minus 5 times negative 5 over 2 times negative 5 squared minus 7 times minus 5 squared minus 4. You'll get 25 over 27. Hence, answer is 1, 1/3 and minus 5, 25 over 27. So this is our final answer. Let's head on to the next question. Okay, so here we need to sketch C, stating the coordinates of the intersections with the axes. So in order to do this, let's first sketch the x and y axis, use the entire space provided. So this is your x-axis and your y-axis. And now let's sketch our asymptotes that we have. So let's sketch y equals to 1. So that's something like this. Y equals to 1. And then x equals to 4. X equals to 4. Then x equals to -12, which is a vertical asymptote. Okay. And now let's find the x and y intercepts. So let's find the y-intercept first. So you do that by substituting x equals to 0 into the original function. So 2 minus 7 minus 4. Oh, you get 0. So this is the y-intercept. Okay. Alright, and now let's find the x-intercept. So you just equate the numerator of the rational function to 0. So 2x squared minus 5x equals to 0. You'll get x times 2x minus 5 equals to 0. So we already got x equals to 0. Now 2x minus 5 equals to 0. That will be x equals to 5 over 2. So 5 over 2, that is somewhere here. Yeah, somewhere here. Okay. Alright, so in order to do this, let's sketch the first branch. Okay, so the first branch would be between the vertical asymptotes, so somewhere here. Yeah, this is the first vertical asymptote. Okay, and then the second stationary point is -5 and 25 over 27, which is right below y equals to 1. -5 is around here. So yeah, so this is the other branch, and the other branch is here. Okay, so this is our final answer for this part. Oh, I did not write down the coordinates of the coordinates of the intersection. So that's just 0, 0 and -5 over 2, 0. Alright. Okay, and now for the next part, we're gonna have to sketch the curve with this equation, the modulus of this. So sketching this is really simple. You just take the part of the curve below the x-axis and you reflect it over the y-axis. Okay, so let's sketch the original curve. Oh my, wait, sorry. I'll try to be as accurate as I can. Alright. Okay. Okay. Then Okay, so this is the sketch of our curve, of the version of this curve, with the whole function being under modulus sign. Okay, so this is our final answer. Let's head on to the final part. So here we have to find in exact form the set of values of x for which this equation holds true. So to solve this equation, we have to first look at our function that we sketched in here. Okay, so 1 over 9, the line y equals to 1 over 9 would be somewhere here. It would be below this turning point, which would now be 1/1/3, which is now the coordinates is 1/1/3. Okay, so these are the critical points that we have to find. Okay, yeah. And let's see if it passes through the stationary point. Nope, it doesn't. Okay, so yeah, these are the 4 points that we have to find. Okay, so yeah, let's find all these 4 points. So to find that, just equate the original equation of the curve to 1 over 9, and then it will get you these 2 points which I've marked with a cross. So cross multiply equals to 2x squared minus 7x minus 4. Simplify, you'll get 16x squared minus 45x plus 7, which is minus 38x plus 4 equals to 0. Okay, and now 8x squared minus 19x plus 2 equals to 0. Then x would just, let's use the quadratic formula. So minus b plus minus b squared. 19 squared minus 4ac over 2a. So x would be, let me type it into my calculator. So this would be 19 over 16 plus 3 over 16 square root 33, and the other one would just be the reciprocal, 19 over 16 minus 3 over 16 square root 33. Okay, to find this second point, we're going to have to equate the original equation of the curve with negative 1 over 9, because to find these points, okay, sorry, so no, alright, never mind. So the previous 2 points that we found were actually these points that I have not crossed. So now we're gonna find these 2 points that I have circled. Alright, so to find that, we're gonna have to equate it to minus 1 over 9. So this would give us 18x squared minus 45x equals 2 minus 2x squared plus 7x plus 4. Okay, so simplifying all that, we'll get to 20x squared minus 45 minus 7, that's minus 19x. Wait, no, minus 45 minus 7. That's, oh, minus 52x, sorry. Minus 4 equals to 0. Okay, now let's divide everything by 2, so 10x squared minus 26x minus 2 equals to 0, so x would be equals to minus b, that's 26, plus minus b squared, which is 26 squared, minus 4 times 10, a, and then c is minus 2, over 2 times a. So x would just be 10 minus 26 minus 2. So this would just be 13 over 10 plus 3 over 10, 21. And the other one would just be the reciprocal, 13 over 10 minus 3 over 10 square root 21. Okay, so we have found these 2 points, and our answer would be in between this range and this range. So that would be, so that would just be 13 over 10 minus 3 over 10 square root 21 x, the upper bound, which is the lower of the solution. So 19 over 16 minus 18 over 16, wait, no, 3 over 16, sorry, square root 32. Okay, okay, and second one, 13 over 10 plus 3, wait, oh god, I have to check which one is, okay, wait, let me see, 13 over 10 plus, okay, 13 over 10 plus 3 over 10 square 21, that's, oh my gosh, okay, 2.67, and 19 over 16 plus over 16 square root 33, okay, alright, the second, okay, the second one, it would be 19 over 16 plus 3 over 16 square root 33 x 13 over 10 plus 3 over 10 square root 21. So these two are our final answers. These are the set of values of x, and we have also come to the end of this paper. So I hope you found this video useful, and if you did, please make sure to like and subscribe for more future past paper solving videos. And if you have any questions or queries about the questions in this video, or would like me to cover other papers in further math and math, please let me know down in the comments below, and I'll see you again next time. Okay, thank you.